we're taking a look back again at some of our properties we've been doing with some of the logarithms and stuff like that as we move forward. So just a couple of things to keep note of. When we're doing our logs, okay, evaluate, another fancy word for solve. So we have got some new tools in the toolbox since the last time we started doing this. So here's some options that I have. Here I think, at least to me, here I feel is the best option. Remember, what we're trying to do is we're trying to figure out, this is my base. What power do I need to take this base to get this value? Now, that may seem kind of tricky, and it is in some ways, but there's some things, hopefully, we're starting to kind of make a connection with here. Okay? Now, I agree. Nice! Even better. Okay? Because we've talked before how we want to deal with these. We know for sure that since I had to flip this, 7, whatever's going to go to the bottom, we know it's going to be negative. And now at this point, I guess I don't need this, we've just got to figure out, because I'm not giving you any screwball ones down here, 7 to what power is going to be, 343. And if you plug into 3, oh, there it is. Okay. That's basically all you're doing with those up there. So again, we don't really need to play around with a bunch of other tricks trying to figure out all that stuff. That's what I'm trying to do. Now, if I was desperate, if my brain just went to mush, let's say, and I just couldn't remember how to do this, here's my other option. We did that thing called change a base on Friday, where everything gets done on the calculator. So here's how that works again. You take the log of your physically bigger number, so in this case, the 1 over 343. Okay, and then you divide by the log of my base number, my little number here. And I get the same answer. Okay, they both work. But again, there's an advantage to doing it without the calculator in that when we get to the equation solving, there's going to be some of those skills you're going to need to make it go faster. I'm not going to be able to just go to the calculator. But it's a good backup plan or a good way to check your answer if you need to do that. Okay. Expanding our logarithms. Okay, we're going to go from one term, we're going to stretch it out and make it really big. Okay. So a few reminders to remind ourselves of. If I see division, if I see a fraction, remember that is going to turn into subtraction. Okay, division is subtraction. Lots of shins. Division, fraction, subtraction. If I see multiplication, that's right. Multiplication is going to be add. And then my final one that I can run into if I have exponents, if I'm going to a power, they're going to swing back to the front and become coefficients. And the cool thing is when we get done with this section and go to condense, it's all going to be backwards. So if I remember them, even if I jot them down, which isn't a bad idea, then I can kind of work the process backwards from there. Now, here's the kicker though. Here's where this gets kind of interesting. And I'm actually, where do I want to go here? I'm thinking number 8 is probably where I'm going to go. That does look kind of gross. Actually, we're going to tackle a couple of these. We're going to tackle 5 and 8 because I see another dilemma. I'm glad we're all in agreement here. So, okay, let's start at 5. Because there's going to be a temptation when you're doing number 5 to take this 5 and stick it in front of the log. And I can see why you'd think that. But when there's multiple terms to work with, my first job is going to be to distribute that through. And that's the only time I'm going to do something like that. Okay? Like on number 6, I can just do things individually.
So it'd be U15.
Exactly. So I've got u to the 15th, because when we're going power to power, we multiply the exponents, and v to the 5. Okay, that'll take care of that first part. So then I look, I'm like, okay, is there any division? No, I don't see any division. Multiplication, okay? If I was doing multiplication, there'd be a multiplication dot between the u to the 15th and the v to the 5th. So here's how I tackle that. Wherever that dot would be, that's where I'm going to put my plus sign. And then I have to rewrite my log with its base in with each term that I have. So if I had 5 terms here, I'd have to write log 8 5 times. So we took care of the division issue, but there wasn't one. Okay, we took care of the multiplication. And probably if I had this to do in an order, I'd probably do the multiplication first, but there's ways around it. And then finally, if I have exponents when I get to the very end, those exponents become coefficients at the beginning of these. So I end up with 15 log base 8 of u plus 5 log base 8 of v. No more exponents, no more multiplying, no more division. I've expanded my logarithm.
So does that 8 really play any role in it?
That 8 would play a role if I had a value for u or v and I was plugging it in and I was like punching it in the calculator with a change of base. Yes, that absolutely would have an impact. When you're just expanding or condensing, though, it's really not going to make as much of a difference. But yeah, once we start plugging values in, that number makes a lot of difference, actually.
Values on the
Not for when you're doing expand or condense, no. But when we get to equations here in the next part, yes, then we'll start doing that. Okay. And then, as promised, number 8, I can't remember the wording we used, but the ugly one. Gross, thank you. Okay, here's my dilemma. I'm looking at that square root, or in this case, a cubed root. I need to look at this part in its exponent form.
Why are we looking at the z that's also in?
Well, we are going to be looking at that. I'm just going to rewrite this first part. But for me to continue with this, I need that cubed root part. That's what's kind of messed up here. So, a couple of questions. First, what exponent's on my x when I don't see one? 1. So now that means if I were to write this in its exponential form, it's exponent over root. So that's x to the 1/3. Okay, and that's the way I'm going to look at it when I'm doing this. So once I've got it in that form, I start to look and I'm like, okay, now what can I do here? Bless you. I don't see any division, but I do see multiplication. So, job 1. And I'm going to beat some of you to the punch here because I know a question that's coming. So once I write this, I'll answer it. Some of you are going to ask me, well, I already know that it's going to be plus, and I already know that I'm going to swing those exponents down. So can I just do it all at once? Yes, but I always put that with a but don't go too fast or you may do something silly and then you end up losing points, and who wants to do that? So, exponents swing to the front. No more exponents. No more multiply. No fractions. We're done. But again, I've got to keep track of my 3 basic rules. If I don't know the 3 basic rules, I've got no chance with these. So I got, sure. Yep. Distribute first. Multiply when you're going power to power. Yep.
Even though there's, so like for y, there's no number next to it, so it would be 1?
Yes. Good questions. So yes. On 7, you would start by multiplying your exponents to clean that part up, and then you'd go ahead and start expanding it. Okay. So let's see if I can keep all this in the screen here. Okay, condense each expression to a single logarithm. Okay, condense. Everything we just did up above, we're now doing it backwards. So if I see a coefficient, it's turning into an exponent. That's going to be my first job. If I see any addition, that's going to turn back into multiplication. And if I see any subtraction, it turns back into a fraction. So I'm basically going to work my steps backwards because that's the easiest route to go. I'm not saying it's the only way, I'm just saying it's the easiest. So let's say we're doing number 9. And yes, we'll do number 12. I know, gross, ugly, yeah. So I see coefficients. Those are going to swing back into becoming exponents. So I get that situated first. Then I look and I'm like, okay, let's see here. Took care of that. Is there any addition? Ooh, there is. Okay, that becomes my next job. So here's how this works. Because when it says a single logarithm, I shouldn't see any more pluses, minuses, anything like that when I get to the end. So I've got log 9 x to the third times y to the third. Basically, I'm replacing the plus with a times sign. And really, the only thing that can get this messed up at this point, and it's not a huge mistake, but it's one you'd lose a little bit of point on, I've got to remember to put this in parentheses. And the reason behind that is, if I didn't have parentheses there, okay, we would assume this log base 9 would only go with the x to the third, that it wasn't going to the y, and it is, because we see that right here. So make sure your final answer, you've always got parentheses around your part that has, your variables in it. Okay. And 12 we're basically just going to do because I don't want you spazzing out. So we're going to come down a little bit. We're going to rewrite something here first, and then we'll get down to business. Okay, the log 4d, that's not going to mess with us much. Let's look at these with fractional coefficients instead. Remember, there would be a 1 in front of all of these if I wanted it there. So this is really just 1/2 log base 4 of a, and 1/2 log base 4 of b. And that's true if there's any number. If there's a 4 under here, if there's a 2 up here and a 3, just turn it into a fraction and make it a coefficient. Log base 4 of c. Okay. Now, does it make it look a whole lot prettier? No. But at least it puts it into a form where I can start to figure out how this is all going to work out. So you're like, okay, so all these 1/2s I just got done right now, all got to turn back into exponents, and that's true. Yeah, we're going to have to kind of go up the side here a little bit because this is going to get a little complex. Trying to figure out, it'd be kind of funny looking on this video if I turned my paper sideways, but I'm going to try not to. I'll just kind of scooch this over a bit. So again, once I got the 1/2s, I've turned them into exponents because that's my first step, coefficients back into exponents like we talked about up there. And so then my last step now is I see a whole bunch of addition signs, which are going to become multiplication. And again, since we're doing this in a single logarithm, let's kind of do this, because we got plenty of room for 14. Okay, single logarithm. So I've got d times a to the 1/2 times b to the 1/2. And I really don't have to put the multiplication dots in there. I could just write d a to the 1/2, b to the 1/2, c to the 1/2, but either way is fine. But again, one logarithm. No pluses, no minuses, okay? None of that. So that one's done. Okay, so again, add becomes multiply, minus becomes divide, or fraction, okay? And that's it. So again, not terrible. Not terrible at all. Now, when we start getting ready to look at the back here in a minute, we're going to hit up some graphing again and a little bit more with some solving of some stuff and things like that. But as you practice this, as you get some more work with it, it does become easier. So we're going to do one of these. Okay, so 16 here. Let's go ahead and do that one. It says name the transformations. Reminder, transformation. Fancy name for shift. Okay? If there are shifts, you need to let me know what those are, because that's going to kind of help me see whether, if you had a problem with your graph, why that would be. There you go. Identify the domain and range, sketch the graph. Okay, I'm already being told what the shifts are, so we'll get that taken care of. So right 1 and down 4. Now reminder, again, we talked before last week. I got a couple ways I can graph this. Okay, when I go to graph, my 2 base points when I'm graphing logarithms are 1, 0, and 10, 1. So if I want to, I can just take those and do the shift and just have my 2 points and I'm set. That's kind of cool. So here's 1, 0, but I'm going to go right 1 and down 4. Now this one a little bit crazy again because I made the graph a little small. So 10, 1, go right 1, even further out. 1, 2, 3, 4. Now before I connect the dots so I don't do something silly, where's my asymptote going to be? Okay, my asymptote is going to be at 1 because normally it's at 0, but if I have a left or a right shift, it moves. Okay, so I'm even going to write that in. My vertical asymptote is at x equals 1. Because now when I go to take my 2 points and make my graph, I'm not going to get silly and start drawing and have it end up like way over here somewhere. That's not good. Because that asymptote's like a wall. It makes my graph stop there. Okay, or I can get close, it just can't step over. So, we've got that part down. What about my domain? Start at 1. Go to infinity because there's a direct connection with my vertical asymptote. That's right. And then my range is negative infinity to infinity because it goes down forever. And even though it's a little harder to see, this is going to keep going up ever so slightly, but it's still going up and up and up. And then we're set. So not a bad deal. But again, keep writing down those shifts. Now, I will do this. I wasn't going to, but I will, because I want some of you to feel comfortable with this. If what we just did, you're like 10, 1, 1, 0, I don't know what he's talking about. Okay, if you have a brain cramp on this, we can tackle and get what we need out of the calculator. I'd look at my chart. First place that I see the error message, okay, that's where my vertical asymptote's at, so that can help me out there. That's also where my domain, of course, is going to start. Right there, because I don't have any values before that. And check out my points. 2, -4, just like we did when we shifted it. And my other one, there it is. 11, because I was out here a little ways. And down 3. So I can do it with the calculator if I need it. I don't think you're going to need it, though. If you've practiced it, I really don't think you're going to need that. All right. A couple more things down here at the bottom. Okay. Rewrite in exponential form. Notice, doesn't say evaluate, doesn't say solve, just rewrite. So remember how these work. If I do it right, it should make a true statement. So let's say I'm doing number 19. Okay, we keep saying how this little log number, that's my base. 18 is my base, okay. So 18. Now, is 18 to the 324th power equal 2? No, that doesn't make any sense. does 18 to the second power equal 324? If you're not sure, and I can understand why you might not be, check. 18 squared, 324. It's a true statement. I did this right. So base, exponent, answer. That's how these set up. And that's all I got to do. And the cool thing is, now you got an example for the next part. So when you get down to 22 and it says rewrite in logarithmic form, now it wants me to go from this back to this. So even if I'm not sure, now I got an example and I can go, okay, let's see, how's this work? Okay, I got to put log in here somewhere. Okay, that is my base. That is my base. Okay, log 16. Okay, I got that part. The exponent seems to be on the equals side. So the exponent's 2. Okay, that goes on the equals side. And I got nowhere else to put this. I'll put it here. Okay, and there's even a way, remember, to double check this to make sure it's right. See, the cool thing with logarithms is there's always a way to check. Well, how do I check? I do that change of base thing that we were talking about. I take the log of the physically bigger number, log of 256, and I divide it by the log of my base, 16. 2. I know I'm right now. Nothing better than turning in a quiz with questions you know are right because you just checked them. Okay. Now, like I said, the review will be coming tomorrow. If you want the review from me today, I'll give it to you so you can get a heads up. But a majority of what's on that quiz is going to be this, except some of the application problems that we were doing before. So, hey, if you're rolling now, just keep rolling with it.